Good morning. Here's attendance. You're Elijah, right? Yep. Fred here? Freddie? Oh. I put up there the next review, right? I've already put that online. Can't remember. I've been out of town for 5 days. So today we're going to go, we're going to start on 17 and 18. Wednesday we'll cover 19 and 20. And then we have our next test a week from today. And then we have a field trip the day after that. So I'll hand out more information on the field trip probably next Monday, or I'll put it on Canvas. I have to contact the builder that we're touring with and make sure where we're going to meet. I still have not gotten very many extra credit details, so, and you guys need to be working on your final projects too, so I know some of you do need details. So let's get with it on those. All right, so let's go over 17 and then we're going to do a little exercise. Okay. So 17 and 18 are about glass and glazing, and then exterior wall systems. And like I said, I'm not going to, this is all online so you can read it yourself. I'll just try to hit the high points. The history of glass. Glass is a very old product. It's very strong. It's stronger than you think. I toured a house this weekend at the TSA convention that had, I should have pictures. I do on somewhere, but it'll take me too long to get them up. But it had, of course, the guy that owned it was a zillionaire, but it had this multi-level thing, and it had this pool with a lap pool with glass wall at the end of it, so you felt like you were swimming, and then you look down and it's like a 30-foot drop. And over that went a bridge that you walked on glass. And the connection between the old and the new house where, no, I didn't bring that in here, where all was this glass bridge, so you walked over the lap pool, which is 30 feet below, on this glass bridge. Just, I mean, glass is strong. So, the part we walked on was probably about that thick, and it was maybe in spans of 5 or 6 feet held by black steel beams. I wish I got in at 11 last night, so I couldn't think about putting them on a lecture for you, but maybe I'll put them on Canvas if I think about it, just so y'all can see it. But anyway, it's a very strong material, and these slides that you can read and read about in the text just talk about how glass was first made, you know, the blowing process, and then it gets into how it went from crown glass to float glass. You know, as the name implies, it was floated and set or cured in the float process. And then they started, you know, like all materials, it started, you know, finding ways to make it stronger and more insulated and different things to keep it from breaking. One of the main problems with, I guess, or concerns with glass is the breaking or fireproofing. So like that door right there, that glass has to be 1 hour rated to be in that door, because that's a 1 hour rated wall, meaning it can't fall down for an hour in a fire. And so that glass, you know, used to be in old buildings you see wire glass. That's how they made it where it wouldn't combust or fall apart. But now there's layers of laminate and stuff in there, or annealing or whatever, to make it, you can make bigger pieces that are actually fire rated glass, and they'll stand up to the heat and the load. And the slides, they talk about, you know, like I just said, the way it's improved, and how basically you can have glass walls, and you can have different appearances by the films you put on it, and it can reflect the sun, it can let the sun in, it can let keep the UV out but let the sun in, all kinds of stuff. Basic ingredients are the same as always: sand, soda ash, lime, alumina, and potassium oxide. Sand being the major ingredient that's always been used in glass. Thicknesses range from what, depending on what you need, very thin, 3/32, up to very thick, an inch or even thicker nowadays. Tempering is the heat treatment that they use for impact glass, and basically it describes it in here. You cut the annealed glass to a required size, you reheat it to make it strong again, you cool it rapidly, and that keeps it, instead of breaking into large knife-like shapes, it crumbles into little crumbs. That's what your windshields are made of, and any glass that is near the floor, like on a door or a side light to a door, that all has to be that kind of glass, because you don't want children or anybody running into it and then having this giant shard of glass cut them. So this talks about the different types of glass in this slide. Like I said, annealed, tempered, heat strengthened, laminated, and fire rated. Laminated glass is what they use for impact glass nowadays. It's basically layers of glass with thin plastic layers between it, sometimes 2 or 3 layers thick. You can have patterned glass or fritted glass where it's like a pattern etched in it. In this house, the bridge that went over the little pool had fritted glass, because if you didn't have the frosted little pattern, you would look down and feel like you were going to fall in the water, because you would have no perception that there was something there. So that was a safety, although it still was scary. that was a safety element to have the fritted glass. Spandrel glass is a term used. You see these high-rise buildings sometimes that have it appears like a dark stripe and then a clear stripe and a dark stripe. The dark stripe is the spandrel glass, and that's the glass. It's still glass, but it hides, because if you I can't draw in there. If you're looking at a building and it's got floors, so many floors, 100 floors, then you've got, this is all the structure, the floor, and you don't want to see the pipes and things, so you'll have a piece of spandrel glass that hides that's the dark glass. And then you'll have your section of clear glass, so from the inside you can see out, but from the outside you cannot see in on this part. So your vision is blocked, basically. I'm going to do like that. And then you'd have another spandrel and then another clear. So spandrel is a type of colored or opaque glass that keeps you from seeing what's behind it, but it still gives the reflectivity. On the outside it looks like glass, so it looks like the whole building's made of glass. I think there's a better picture of it here in a minute. You can kind of see the stripes on this building. So this thinner stripe would be a spandrel glass, and then that would be the see-through glass that the people inside can see out of. And it's always going to be tinted somewhat nowadays, because you have to have that tinted aspect to keep, the heat gain. You don't want the heat melting you. So here's just a picture of what, how the sun would react coming through just plain old clear float glass, which is basic glass. You get a lot of that heat and radiation going in. Then you get some reflective glass. A lot of it gets bounced off, some of it comes in. And then with more modern insulated double glazing, you get very little of the heat going in, and a lot just reflected out or absorbed. And this just talks about more aspects of thermal glass and how it works. These are different properties you need to be aware of when you specify your glass, because different buildings may require different aspects, so you need to understand how to look these properties up in the glass manuals. And then when you get your glass at the site, it'll always have these labels on it. So then, as an architect, when you're going out to the site to inspect on your weekly inspection and say they've delivered the glass, you'll have to check these numbers against what you specified back here in your specifications. Make sure that they're not trying to cheat you and get something cheaper. And as the architect, you can reject that and send it back and make them start over. It's great power. So glazing is a term. That door right there is glazing because it's not really an exterior application. It doesn't have a lot. I mean, the only thing it has to worry about is the fire code. So these are like panes of glass, and these are just different terms of how the glass is, details of how it's set. These are things you could draw for me for 5 points each. So just be familiar with, and this is a section through a piece of glass, and you have your wood that's holding it in there. They put the glass in, and then they put a glazing compound in a point, which is like a little pin. Here's another way to do it. You just set it against, you got your wood trim, and then you put another wood stop there. These are kind of older ways. Then you got, when you have metal frames, you have a glazing compound, kind of like a putty that you set it in, and then it gets hard. This is a metal frame that then you snap in this bead that holds in the glass, and you got a synthetic gasket right here. That's this little black part, and that keeps it in place. Here's a picture of them putting in some large pieces of glazing. Here's some more ways to put glass in for large lights that have, you know, a large light meaning on the outside of a building, a high rise, it has maybe a piece of glass that's 6 by 8 feet or something. So you'd have to have a stronger frame, obviously. There's just another picture of a guy putting the strips in there. And different you know, effects you can get. This is called a muttonless butt joint glazing. You know, you can barely see the joints of the glass, so it appears like it's just a solid ribbon of glass, and it's very an uninterrupted view. Very expensive too. Here's what that might look like from the outside. You know, this is just a ribbon of glass that goes very few joints in it, or visible joints. That's the detail, like that's called an axonometric. It's an angled detail of what it might look like. You do have the frame behind it sometimes, and then you have the piece of glass that butts up into the next one, and there's just a thin piece of glazing on the outside. There's I mean, that you barely see the framework in that building. It's kind of cool. There's more details on how, I mean, y'all need to study these, you know, as you read through the chapter and understand what they're doing. The framework is behind the glass, and then, you know, they'll put one piece on and then the next piece on, and then it's locked into place. It's all done from behind. There's another one. Here's a cool system, suspended glazing. You can see these rods are coming down from the structure, and then it's holding these glass pieces on. Very, very minimal. That's what it looks like up close. You got this kind of suction looking thing, and there is probably a screw or something that goes through that really holds that into place, but it's a very minimal looking structure. There's another picture looking through it. It looks like it's at an airport or something. Mm-hmm.
What goes into it? Is it just like that?
The sports place? Is that what you're talking about? I haven't looked at that closely, but I mean, it's probably something like we looked at back here, like that. More of a frame and then the glass on the outside. It's probably something like that has a framework inside. Next time you're there, you should look at it. I've never thought to look at it when I was there. I haven't been there in a while. Oh, I passed up where I was. Hold on. Okay, anyway. You can use glass, like in this case, on roofs. You just have to be careful, again, for leaking. You've got to make sure all the joints are sealed. They even have glass here sort of acting as beams, holding that up, because it's a very strong material.
Heavy too,
Huh?
right? Heavy.
Heavy and, yeah, I mean, yeah. Especially when you're using it for structure like this. Can y'all see that piece of glass acting as a little beam, holding up the roof? Can y'all see on your screens?
No.
Oh, sorry. Why didn't you say something? I thought I put it on there. Can you see on yours?
I think it's just a couple of us, but you can see them.
Can you see yours? You guys got to speak up. I notice you're all looking up here. Let me see. Hold on. Some people can and some people can't. Huh. It's only showing like 6 computers on. I don't know how to fix that. Show teachers. Stop showing teacher screen. Windowed. Continue. Can you see anything now? Well, I guess. And your computers are on and they appear to be working?
It's all right.
Okay. Let's see. Now I got to get back to my slideshow. Slideshow from current slide. All right. Well, sorry about that. I'll report that to the help desk. Of course, there's decorative glass, stained glass, which we see a lot in churches. That's very old. I mean, that's a very ancient type of glass that they used. And this is where you would find glass in your specifications. In the section 8 talks about everything you ever needed to know and how to specify glass. Now I got a movie. Hope y'all can see this. Let's see. Video on, you know, I need to try to find a newer version, I think. It's kind of fuzzy, but let's see. Okay, so now we're going into chapter 18, which talks about windows and doors. And these are this will go over some terms that you need to be very familiar with as architects when you become architects or just designers. The terminology is something that you use quite often. You need to understand what the jamb is. And the jamb is the connection or the support between the wall and the window or the door. You have the sash, which holds the glass in this case. You have the sill, which is the bottom part. You have the apron, which basically just covers whatever gap there might be between the sill and the structure. Exterior casing, interior casing. All of these things you need to be pretty familiar with as terms because you can detail them. These are different types of windows. Fixed, obviously, fixed glass, you know, nothing moves. It's single hung means one, it's usually divided equally in two, and one portion of it will go up and down, usually the bottom. So that's single hung. Double hung is when both portions will go up and down. Sliding obviously goes back and forth. Casement is window is kind of like a door. It's the kind that swings out. You know, you kind of crank it and it swings out or in, I guess. Awning is an apron. It swings like you know, goes up and down. Hopper is the opposite of awning. It goes like that. I'm not sure why that has the name Hopper. Then you've got roof windows. Skylight basically is a fixed roof window, and a roof. And this one would be like an awning roof window where you can open it up if you want to let the hot air out or cool air in. Then you've also got different types of glass doors. You've got a terrace. This is called the terrace door, where just one leaf operates. It appears like a French door, but only one side will open back and forth. French doors where both sides open, and a sliding door, obviously, they slide back and forth. So especially when you're doing, residential design, you have to know all of these terms to be able to talk to your client about what types of windows they want. And then larger buildings, top hinged, in-swinging, side hinged, in-swinging, pivoting. It sort of pivots from the middle. Not too many skyscrapers have operable windows, although fresh air is becoming more and more important, so they're trying to think of ways where you can have a little bit of opening, in newer buildings. Of course, you've got to worry about things falling out or coming in, so it can't be too big. But here's a building with, it's called a strip window system, where it's basically just the fixed glazing on a ribbon window like we saw in the last chapter. And then you got the frame that holds the window. Double hung wood window frames, that's what this picture is right here. This is an aluminum clad wood framed window. Half of it's wood, half of it's aluminum. And then here is wood windows and double hung, different configurations. Traditionally, the windows like in old colonial houses were made of wood, but that tends to shrink and swell, and then you got to scrape it and repaint it and blah, blah, blah. So then they came up with vinyl covered wood, which you've all seen those kind, and it takes away the need for the scraping and the painting. There's also now solid vinyl windows that look like wood, but the whole thing is just a piece of extruded vinyl. And they got the aluminum or the metal windows. The trouble with the metal type windows, especially in a residential situation, is that the metal will conduct the heat or the cold. And so, you go and touch it. If it's very hot outside, you'll feel very warm. If it's very cold, you'll feel very cold. But the wood and the vinyl tend to absorb that a lot better and don't let the hot or the cold through as easily. Here's some details that you could copy, 5 points each for your extra credit. And this shows, if you study this picture here, just sit down, you're looking at the front elevation, the front view of a window right here. It's a double hung window. So this detail number 4 is the head. So, and this is a metal frame situation or aluminum. See number 4 right there, so you're cutting through this part right here, looking sideways, to the left or to the right. So when you do that, you see all of this information. You've got your frame and your dimensions, and then you got your glass and all that stuff. Number 9 is where the two up and down parts meet. You can see that here. This part would come down. This part would go. Oops, sorry. That part would go up. So that's cutting through right there. Number 3 is the sill or the bottom part of the window. So you can see the base and then how the window part locks into that. Number 16 is the jamb or the side, and that looks pretty much the same on either top or bottom. So in this case, you're cutting through that and looking down or up. So that's called the window jamb. So those are details you should be familiar with. Let's see, just more terminology. There's a picture of the thermal break is what they use in metal windows, that piece of rubber right there. And that stops the cold or the hot from conducting all the way through. So if this was the outside over here and it was really cold, this piece of rubber would stop the cold, and then this on the inside would stay relatively room temperature. Here's a picture of aluminum, commercial grade aluminum windows. There's what you're seeing when you make your little sections. They cut that window in half so you can see what you're looking at, what we just saw a few minutes ago. And then oftentimes when you start out in offices, you'll be asked to draw these things because it's very important how you detail it, so that it doesn't, the contractor knows where you want your waterproofing and how things work so it doesn't leak. Here's just some more pictures of window frames. Muttons are when the glass in the window is divided into small sections within each sash by muttons. So these, might be called muttons right here, if you can see where I'm pointing. Here's some steel window frames, and here you can see a picture of the wired glass that, this is an older version that's used for the fire glass. Nowadays you don't have to have the wire in it because there's a process laminating it that makes it fireproof. Here they cut through that so you can see how the metal works and the glass sticks up in there. Here's some more details you could copy, 5 points each. Again, you got number 1 is the head or the top of the window cutting through. Number 2 right here is the middle section. Number 4 and number 5 are jambs. Here's number 4. Here's number 5. Number 3 is the sill. This is the whole window right here. Sort of, you got 1, 2, and 3 different types. What this is showing is PVC versus aluminum. This one over here is aluminum. This one's PVC. PVC being the plastic type. Still got the same basic parts, but it's just formed a little differently. Here's some comparisons, which you need to understand this when you're specifying, the U factor and low E, how much heat will go in, in comparing the different materials on that. Vinyl obviously expands quite a bit. Well, I think, no, thermal expansion, yeah. Here's some details again. You could draw these, copy these for 5 points each. A lot of times the manufacturers will give you details, like if you have to draw in Revit or CAD. Of course, you need to draw these by hand if you're copying for me. But you can plug these into your drawings. The manufacturers will go ahead and give it to them, but you still need to understand what it all means. This is a section through the whole window. This is a wood frame construction. You can see the pieces of wood here is the header. Then they cut it because they don't want to draw the whole length, but this is the jamb or the sill and the top head right here. And this is one of those awning, some sort of cranking type window. Here's just a picture of a window being installed. And then we get into doors, which also have their own terminology. Some of it's similar, some of it's not. But you need to understand what they all mean. Swinging doors, obviously they swing. Bifold means like a closet door, they bifold, that means in two. Accordion is like an accordion, goes back like that. Pocket sliding means it goes into the wall. You've seen those. Bypass sliding means they go back and forth across each other. Surface sliding means the frame, instead of going into the wall, there's a frame on the outside of the wall, so the door will just slide over the outside of the wall. Overhead is like a garage door, goes up and into the ceiling space. Coiling means it rolls up and goes up and rolls up. So those are terms you need to be familiar with as a designers. Then you have different configurations for your doors. You got flush, which is just a plain door. Glass, usually half glass, full glass, narrow light, as the name implies. A single panel, meaning the door is usually wood or some sort of a composite material, but it has like an inlay single panel. Here's 2 panel, 4 panel, 6 panel. Here's a panel with some glass. Here's a glass with mullions. Here's a louvered door, meaning these can rotate open to allow air through. And this might be a storm or a screen door. And here's some more for steel doors. Usually in commercial applications you'll have steel doors. Again, you have flush, which is just one, just a plain door. Vision has 1 piece of glass, usually up top. Louvered again. Vision with louvered. Glass, full glass, louvered, narrow light. And here they're showing details of hollow steel door frames. Usually doors, especially in commercial applications, will come the frame and the door already assembled, and then you just put it into the wall opening. And this is showing you details where C is the jamb. You can see how you got the extruded frame, and then there's these little things that go into the wall, and you attach that with screws to the studs. Number B, where's that one? That's showing how they reinforce it at the hinge with some blocking, usually some wood blocking behind the frame. A is how it attaches at the floor. It'll be some reinforcing with some fasteners into the floor. There's a picture of a steel door in concrete masonry. And this is a fire door. According to the codes, a lot of times you have to have, like if you ever been to a hotel where there's an elevator bank, usually if you look closely, there's doors that will automatically enclose that elevator section so that this smoke will not go one way or the other. So this is a fire door, and in the event of a fire, that door will automatically swing shut. But you probably don't really notice it when you're just there because it's all flush with the wall. There's some that are better concealed than others. But also they will have a label if it's a fire door right there. Let me see if this door has one on it. It should. No, it doesn't. That's bad. It might be on the bottom or something, or maybe somebody took it off. Typically, you're supposed to have one. I don't know if this one does. But that'll tell the fire marshal. Nope, no labels. Oh well. That'll tell the fire marshal that that's a fire-rated wall or fire door. Depending on when the building was built, and the codes would require that. That's just a picture of door hardware is the term we use for the hinges, the knobs, the locks. And you got to specify all that stuff too. So then they have to test windows and doors for whatever they're going to be used for. It talks about measuring the deflection, like in a wind pressure, because also in high rises, you go up and the wind pressure gets a lot higher as you go higher and higher. So the windows and whatever's up there has to be able to withstand that pressure. So it has to go through all kinds of testing. This is another one. I think this movie here is about window testing. Pause that. Seen the impact test. So one misnomer, because I design a lot of houses on the island, and of course even anywhere in Corpus you have to be being aware of the hurricanes, and people want to put these impact resistant windows, hurricane windows, so they don't have to board up. Well, obviously it doesn't mean the window won't break. What it means, what the boards and the impact resistant windows do is keep something from blasting through the window and then creating that hurricane in your house, basically. Letting all the water and wind in and creating a vacuum and destroying the structure. So just because you have the hurricane windows doesn't mean you're safe. I mean, you won't have to replace the window. It's just keeping the structure intact. Hurricane windows typically cost about twice as much as regular windows. The cheapest system probably is if you have regular windows and just put plywood up. It has to be 5/8 inch plywood, and it has to be attached every so often according to the code, or your insurance won't pay for your damage. After that, you can have like the corrugated metal things that you bolt on. You can have roll down shutters, or you can have the hurricane glass. The hurricane glass is probably the same price as a window with a roll down shutter, but it's just two different systems. So anyway, there's a picture of a building, obviously that had a little hurricane damage from hurricane winds, and you can imagine, you know, the windows pop out, and what all's going on inside of that building. I think it was Rita hit Houston. I was there, and you know, this kind of thing happened in the older downtown buildings. The windows would just pop out, and you couldn't walk the streets for a while until, because you don't know what's going to fall out even after the storm, because it's all weakened and everything. So they got to make sure everything's okay. Here is just a typical label you might see on a door frame that would tell you, you know, what you need to know according to your specifications. You've got to think about all these different things when you're designing. You know, fire code, egress, meaning the path of travel to get out of the building in the case of a fire or an emergency. Accessibility is for the ADA or anybody that is vision impaired or handicapped in any way. What might happen to accidental breakage, emergency escape, structural performance, wind and rain, thermal, all of that stuff. As an architect, you have to be aware of what the products you're putting in your building do and how they will perform. Windows and doors, again, are in section 8 of the specs. And that's the end of the lecture. What I thought I'd do, did y'all bring your review sheets did you print those out? Not yet. Well, I was going to give you some answers. Huh? I could put it on well, y'all could open your Canvas. Why don't you do that? But you might need to take notes or something. Or if you have your book, we can look in the back of the book. Let's see if I can find my Canvas. So here I'm looking at chapter 17. I'm not going to go through every single one, but I want to just talk about some of these, and you can jot down what we talk about. So what, you know, the advantages of float glass over drawn glass and over plate glass. Float glass has many fewer distortions than drawn glass. Drawn glass is the original way that it was made, you know, back when they kind of blew glass and drew it out. Float glass, they laid it flat, and then it kind of settled. It's very clear glass. And it's much less expensive than plate glass. So float glass has far fewer distortions than drawn glass, and it is much less expensive than plate glass. Let's see. Has anybody tried to answer any of these? No, not yet? Okay. Well, like I said, I'm not going to do each one. I'm just going to kind of go through. What? Huh? There's 17 pages? Ooh, oh well. Well, this is I'm only talking about 17 and 18 today. So I'm not going to get into the others. What else do you want to know? Pick another question from chapter 17 or 18. Number 12. This one right here. What is the optical quality of ceramic and what is it used for? Is that what you're asking? Well, optical quality ceramics are glass-like materials that are more resistant to thermal breakage and can be used in a variety of fire-rated assemblies. So that would be more like a kind of like a clearish ceramic tile type thing. Sometimes you see those. I haven't seen a lot of that, but.
Can you read that one more time?
Can I what?
Can you read that one more time?
Optical quality ceramics are glass-like materials that are more resistant to thermal breakage and can be used in a variety of fire-rated assemblies. Who can answer this? Glass was not used in buildings until medieval times. What did you say? False. That is correct. What about the next one? When tempered glass breaks, it falls into small granules. True. That is right. Tempered glass is often specified for its high optical quality. False. That is correct. Security glass is reinforced with steel wires. Correct. Spandrel glass is often furnished complete with thermal insulation and a vapor retarder. True. Boy, somebody's done their homework. Okay. Reflective coated glass is used in building facades, functions as a one-way mirror. True. That is right. Tinted glass that absorbs 40% of solar energy will allow only 60% of solar energy to enter the building. Correct. Have you already answered all these, or are you just guessing?
No.
Oh. Insulating glass functions nearly as well as an insulated wall. False. That is correct. Okay, let's see. What else? Somebody else name a question to answer.
22 to 100.
No, one at a time.
25.
25. Which type of glass is most often used in and around exterior doors where pedestrian traffic is heavy? So fritted glass just means that it has like an etched design on it. Fire rated means it withstands a fire rating of up to an hour. Spandrel is the kind of glass like I talked about that basically covers the structure. Tempered glass breaks into little pieces, not shards. And then there's the annealed. So which one of those do you think would be the glass most often used in and around exit doors where pedestrian traffic is heavy?
Consider B or D.
Well, B, since we're not talking about the fire rating in this question, it probably wouldn't be B.
Okay.
But it would be D, the tempered glass. Because then that will, if it does break, it won't, it'll just be little balls of glass. It won't be big, sharp objects.
D, right?
D, yes. Okay, find me another question. Look at this picture right here. The fat arrow, meaning that, in the sketch points to what? What is this piece of? What is this?
Rail?
A what?
The rail?
Nope. Hmm? What? Mullion, yay! Give the man $10. No. Okay. All right, find me another question. We saw this in the slideshow. Well, let's look at, we'll go to that one in a second, but this one, how are the glass panels shown in the photograph most likely supported? You said spider fitting. What else is supporting it? Because that's true, but there's two answers here. What? By rods or cables attached at the 4-point spider fitting. Yes, both of those. Okay, what number did you say?
What was the answer for that?
E and F? Actually, I think that's a typo. I think that should be one answer, but anyway. You said 42? Where are emergency escape and rescue openings generally required? Where are emergency escape and rescue openings generally required?
Is it talking about like an area, like in a school or hospital, or is it talking about like
Well, and that could have a lot of different answers. I think they're referring kind of to a residential setting. So when you're designing a home, you always have to have a certain size window in bedrooms. To I think it's at least a 3 by 5 window that opens halfway. It has to be like 30 square inches. In addition to the door, so you always have to have a second way out of a bedroom in residential settings, and then. I guess this question, the answer they give is for residential purposes. So it's whenever there's bedrooms involved. Of course, in this building here, we have to have egress. But since this question says emergency escape and rescue openings, if somebody's sleeping, you got to be able to get in there and get them out, is the point, I guess. Find me another question. '54. Which of the following is not, excuse me, which of the following is not a frame material for windows? 54. So a frame material is a part of the, like, that holds the frame, not the glass. What'd you say? D or E?
Is it silicone?
Yes, it is silicone. That's usually the stuff you might put to seal it. But the other, you have plastic or vinyl. You got steel frame windows, you got wood frame windows, and you have aluminum frame windows. So that, yes, E is the answer to that. What about this one? Which of the following materials has the highest coefficient of thermal expansion? Wrong. A, vinyl. That's right. We saw that in that chart in the slideshow. What are jams are associated with what? Built-up roofing systems?
Yeah.
Waterproofing at valleys and on steep roofs?
Yeah.
Welding joining seams in a single-ply roof membrane?
Yeah.
Windows?
Yeah.
Or sustainability in the production of plastics and vinyls? D. That's pretty obvious. Okay. If you even were half asleep, you would know that. So. Okay, I haven't gone into any other questions in 17 and 18. We got 7 minutes of free answers left.
66.
66. Is that in this? No, that's up in 19. I'm not doing that one yet.
Oh, that is 19.
While you're looking for a question, let me briefly say, at the beginning of the class I said we had an exam on Monday. It's not going to be on Monday. We're going to go over chapter 21 on Monday, the 18th, which is Yeah, a week from today. Then we have our field trip a week from Wednesday. But on Monday, after Monday, the exam will be take home, or you do it on Canvas on your own time, and it'll be due the following Monday. So,
So we have a week to do it?
hmm?
So then we'll have a week to take our test?
You'll have a week, but once you take it, you have the like whatever time limit it is.
Right.
Yeah. So, any more questions?
So you said that the 25th?
It,
Oh, sorry, the 18th?
well, it'll be released on the 18th, and then you'll have a week. It'll be released after class on the 18th, because we're going to go over chapter 21 on the 18th. And we have a field trip on Wednesday the 20th. And then by the time you come back to class Monday the 25th, you should have taken it.
Okay.
Also, it'll stop like Sunday.
Yeah, something like that. I haven't actually set it up yet. Okay, now we got 6 minutes left. 26. Which word or phrase doesn't belong with the others? That sounds like a preschool song. Okay. Anyway, which word or phrase doesn't belong with the others? A, lock strip gasket. B, setting blocks. C, wedge or roll in gasket. D, performed solid tape sealant. Or E, low emissivity coating. D, what'd you say? No. Lock strip gasket, setting blocks, wedge or rolling gasket, and performed solid tape sealants are all part of things that hold the glass into place in the window frame. And E, low emissivity coating, is the coating, a low E coating that the guy was talking about in the movie that they put on the glass to block the light. So it would be E, low emissivity coating. Or, in layman's terms, low E coating. Find me another one. 27. Which glass manufacturing process has become the worldwide standard? A, float glass. B, plate glass. C, drawn glass. D, molded glass. Or E, extruded glass. Drawn? That's like medieval times.
D.
What?
D.
D, molded? What'd you say, D?
Yeah, D.
Nope. Nope. What's the clearest glass? I mean, we like to see through our glass nowadays. So, huh?
Float.
Float. That's the worldwide standard. Okay? 30. Which of the following has nothing to do with insulating glass? Triple glazing, double glazing, low emissivity or low E, low conductivity, gas between sheets of glass, or tempered glass? Which one of these terms has nothing to do when you're talking about insulation properties of glass?
C.
Wrong, wrong.
C.
No, has nothing to do. Low emissivity is a reflective coating that reflects the heat off of the glass. So that's an insulating property. What? D or E? E is an egg?
Yes.
Yes, tempered glass. All that has to do with is the breaking property. Triple glazing is when you have 3 sheets of glass with an air or gas pocket in between. That obviously insulates. Double glazing is 2 sheets of glass with an air pocket or gas in between. Low E reflects the heat. Low conductivity gas is sometimes they put that between the glass. So that makes...
Can we go through from 43 to 48 on 2 and 4?
In your last 2 minutes, getting the most bang for your buck? Let's see.
Oh, you already did this.
No, we didn't. We did other true and false, I think.
Okay.
Okay. Double hung windows can be made so that the sash pulls out and down for cleaning.
True.
That is correct. Sliding window or sliding glass doors open to their full area.
False.
False. You only open halfway, or a halfway opening. A casement window can only have its insect screen on the interior side.
True.
True, because it opens out, remember? Casement window rotates out, so you can't rotate into the screen. 46. With scientific forestry practices, the quality of wood for window construction is improving.
False.
False. That's kind of a weird question, but 47. Because it is so low in density, aluminum does not conduct heat well.
False.
False. Any metal is a very good conductor of heat and cold. 48. Being a self-protecting metal, aluminum for windows is generally left uncoated.
False.
False. Right. It will anodize and get all specky looking.
What was 46?
46. With scientific forestry practices, the quality of wood for window construction is improving. That was false. Has nothing to do with it. Okay. Thank you for coming. I'll see you.